Alrighty. Son cosas raras. And it looks like we're live. I don't know, I guess. Welcome everybody to a new edition of WebGL from scratch. Start putting some music on.
Yeah, used to think
Alrighty.
I was fine on my own, yeah.
Check my
Had
levels.
a house, but you made it a home. I'll
Bit
be your
down.
light on your darkest day. Just don't love me.
Minus 10 should do.
Half of the way. Used to carry the weight of it all, yeah. Before I had you there to break
Alrighty,
my
so
fall.
where were we?
Ain't no mind to what your friends may
Let's fire this thing up.
Just don't love me half of the way. We're half of the way to being broken hearted. We're half of the way unless you let me in. We're half of the way from being back to the start. So don't love me half of the way. I can see you were lonesome as me, yeah.
Chat.
You said you could have used
Alrighty.
some company, yeah. I chip away, but you
Good.
was on break.
Let me
You
change
still
the framing
love
of
me,
this one.
love me half of the way.
A bit off.
We're half of the way from being broken hearted. We're half
go.
of the way unless you let me in.
Alrighty, so first task for today
From being back to
is gonna be full stream cooling. Because right now we're rendering all of our Steam messes all the time and just letting the WebGL clipping to deal with the fragments that are not on the screen. But all the vertices, operation and all that are getting done. We can just detect if a mesh is on the full stream and by that not rendering it. There's many ways I guess to do this. Whatever. Alrighty, so what we're gonna do is pretty much get for all of our geometries, getting the bounding sphere, meaning a sphere that gets all of our vertices bounded, and get the radius of that, and the center that will be the position of our mesh, so that we can test those spheres against our postrum. So let me check on my notes that I got already here. And yeah, it's gonna be pretty much it. Gonna be using our handy vector class. Geomatrix. Boom. Boomy boom. Let me hide this and this. And right after we did everything, we're just gonna be, let me just copy and paste it because I already had it here. Boom. So basically we're gonna create 3 vectors, one to store our minimum vertices, or max to store the maximum vertex, meaning the one with the maximum x, y and z, and an aux variable to be storing doing our calculations. So we are gonna go through our position array and extracting all the vertices to our auxiliary vector, and then just mining and maxing that with whatever we have stored before. And from that, at the end, we will have for minimum the most to the top and to the left, and to the left vector, and the one that is for the maximum vector. And from there we can just do the distance, and half of that will be the radius of the bounding sphere of this geometry. So with that we got the geometry part covered. let's just move into the mesh, because we need to account also that our meshes could be scaled. So for that, what I'm gonna be doing is just have a line here, and it's gonna introduce boom.
Down on its hands and knees, but why does the shark have teeth? The shark has teeth to eat, and why does a whale have
Fire.
feet? But I don't know.
Cool. So what we're gonna do with that radius, like I say, our mesh could be scaled. So what we're gonna do is get the maximum scale component of all of our 3 scaling components and multiply our radius by that. So in any case, we are gonna be assured that all of our mesh geometry fits inside of the bounding sphere radius we have defined. And of course the center of our sphere for now will be the position. In the future we could have like an origin or something so you can offset the sphere a little bit so you can be more optimized, but for now we are just gonna brute force it and go for just cover the whole mesh the easiest way. So that's our bounding thingies for our meshes and our geometries. Alrighty, what else? Checking my notes. A little bit up and to the left, back and to the left. What else? Around here. Okay, we already have our geometry. Cool. So next step is gonna be pretty much all of on our camera. So like I say, we're gonna be testing this. Now we got like positions, like origins and radius to have spheres or where our meshes are on the scene, on wall space. So what we're gonna do is first we need a place to store the computed frustum of our camera. Frustum, I guess it is, right? Frustum, there you go. And for that, what we're gonna be storing is just 6 planes of our frustum. And what we're gonna do is just create an empty array of 6 elements and map it to an empty normal and a constant. There's many ways to store a plane, but for the calculations we're gonna be doing, like and extracting it from our projection matrix, I think the best way is just to, instead of the vertices of the planes, just store the normal and a constant will be like the width. And that's it. We just have our 6 planes right there, or the storage of our 6 planes. And of course what we're gonna need to be doing is updating it every time we update the transform. So for that, first gonna create a new function here, call it update frustum. Alrighty, and it's gonna call it here whenever we update our transform. We want our frustum also to be updated so we can test to it. Intersect with it, I mean. Alrighty. So, what's this frustum gonna be doing? It's pretty much getting our frustum and our transform matrix, of course, which, as we remember, our transform matrix is actually a projection by your view matrix multiply, so that's pretty much what we need to extract the frustum from there. Boom. And for that, I'm just gonna copy a handy function I got already here. And if you wanna know how I learned to actually do this, pretty much it's all stripped down version of what 3GS dash for this Frustum cooling. So you go pretty much to this class, you will see they also have like a plane class where they turn the normal of a constant. They also have a function to set from a matrix, which is what we're gonna be doing right now. Set from matrix, I think it is. No, set component, sorry. That's what we're gonna be doing, pretty much. And after this, what we're gonna be doing is normalizing it. And as you can see, pretty much it's the same deal. And that's what the normalize function does. It just gets the inverse normal, multiply the normal by that, and scales the constant. So basically that's what we're gonna do on one shot right here. We're just gonna be passing an index of a plane that we want to update, and it's 4 components, and that's gonna be updating our normal and our constant, but already normalizing it for us. So that way we will have our 6 planes, or 6 normals and constant normalized, so we can actually start doing testing the intersections with our spheres. And also, if you want to see the next step, I basically take it from here, which is the sec from matrix. We're basically gonna set all the components of each plane to some values of the projection transform matrix, or whatever you wanna call it. And I already have that part of the code here. And this is pretty much what we're gonna be doing. This we wanted to alias it to M. And like I say, every time we update or transform, we're gonna go through all 6 planes of the Frustum, and we're gonna update with its components. And at the end of the day, what we're gonna have is 6 planes with a normalized normal and constant. So that way, this is the final part of the puzzle. It's gonna be a function called is in Frustum. And this is gonna receive pretty much our sphere, which is gonna be a position and a radius, which, like I said, is pretty much gonna be the position of the mesh plus the radius we calculate every time we update the transform. And for that, what I want to do is, of course, get the first Frustum, and basically go through all the planes until we hit one, I guess. And if not, is that is on the Frustum. Yeah, until it's not on one of them. Yeah, that's right. Right, so like that, so. Y minus Frustum length. That's 1. And for this, we just want to get the signet distance to that plane, so we can compare it to our radius. And that's gonna be pretty much the dot product of our Frustum normal. Oh shit, what is going on? I don't know, I forgot to type suddenly. Alrighty, so the Frustum normal of that very same plane we're testing, and of course the center of the origin plus the constant, I guess it is, right? Right. So that will give us the signet distance. So basically what we want to do is check if it's less than the negative radius, right? I think so. Distance is less than the negative radius. then it's not on the first room. Yeah, so we try to bail as soon as we can. So as long as outside of one of our planes, we consider it is outside. And if it passes all the tests, it will return true and it will be rendered. Check. I think I got everything there. Sweet. So we go to our renderer now. Which is pretty straightforward, I guess, since we already got our meshes right there. Again, just before this, instead of the whole route, we're just gonna get our meshes. It's gonna be pretty much a filtering on the route, getting their position and their radius. Just like I say, it's the actual position of the mesh plus the geometry bounding sphere radius scaled by the maximum scale component of the mesh. And once we filter this, that's the thing that we want to iterate on instead of the actual route. That will be. And finally, here the only thing we need to do is call our camera is in frustum. Basically, I want a position and the radius. There you go. See if this works. First try. Yeah, almost. So this is gonna be frustum normal, constant, right? Ah, sorry, I'm retarded. Wait. There you go. Always on the basic set. That's way up. What can I do? Alrighty. So this will be cooling our meshes. And I guess the only way to test that right now is to actually speed in the count in every frame. Let's just check that. Let's console log. The actual count of the root. And the actual count of our meshes. See, now we're pairing 6 of 6. But if I just go a little bit, 6 of 5. But see, the scaling is working because it's coming when it's scaled and it's going away whenever this triangle gets tiny. And here it should be just these two. Cool. And if I go like that, eventually. Of course, because it's a sphere, so it's gonna be pretty big for this one. Like I said, we probably can optimize that on the future. But as you see, right now it's just showing 1. We can go even to the very end of the plane, and it will still showing up. And there you go. So it looks like it's working. It's working. Right now it's not giving too much of an effect, but when we start having a lot of meshes on the steel, this will definitely make a difference. Alrighty, like I said, because I copied most of the math from 3GS, it was very straightforward. Instead, we update the frustum on every frame and we just use it to test if the spheres of our meshes are inside of it or not. Alrighty, so what's next on the list? Let me check on the chat and see how I'm doing on time. Good, 20 minutes, nice. Lightning fast. Okay, so I think it's time to start using For Real or the Ferrer renderer. And I guess lights, a diffuse and specular lighting should be the proper use for it. Let me check if I got something else hanging in here. I don't think so. Well, there's some touches I want to make to our shader first, to let that be closed for once and for all. I was doing some testing and this doesn't really make too much of a difference. In fact, it's making it kind of worse. So instead of that, we're just gonna get it non-linearized and we're gonna be passing it on the distance to the camera of the fragment. We're also gonna be sampling just one more and correcting this that was incorrect before. So we want it from the center. Right. So that should be it. And finally, the other fix I got was, where are you? Let me just copy this. Will do, and just get all of our textures right here on the same place. Color, then position, normal, should be golden. And it's gonna be deleting this since we're gonna be doing, like I say, we're gonna be passing some lights to this from now on instead of having a hard-coded light. So that should make also Bell look a little bit better, even when we go very far. Because what this does pretty much is the farther we are from the camera, the more of the less of the distance of the depth needs to be in order to paint the line, but the more closer we are, the less distance is required to actually paint a line. I don't know if I'm making sense, but it looks good, so trust me. Anywho, alrighty, let's close this. That should do for that. And lighting, I guess. So the approach I'm gonna be going on this one is pretty much the same as this guy. You go the red. There you go. And yeah, this is pretty much gonna be it. We're just gonna have a structure of lights on our shader. Have the position and the color of the light, and a uniform with a bunch of them as an array. And we already have this already, it's our camera position. And then we're just gonna get all textures like we already do and just do all these calculations for each of the lights. And I just went through this tutorial, check it, and I already wrote some code for us. And for that I'm just gonna create a new file. And since I'm a bit dyslexic, I'm just gonna copy the line in Word. So I type it correctly, DLSL, boom. And like I said, we're gonna have the same structure with our position and the color. We're also gonna be having a hard-coded number of lights. If we don't want to use as many, we can just pass them with 0, 0 on everything, and they will just not affect our scene. Or we can even do this. Well, maybe you cannot do this a uniform because this needs to be constant, but for now I guess it's cool like that. On the future we could do like light volumes and stuff like that, and only because you can if you have like the attenuation of the light, you can get the radius of the light, and with that you can get the light volume. And the same that we do with the spheres of the meshes of the geometry, we can test our light volumes if only render the ones that are inside the frustum, so that way we can even have more than 32 lights, as long as we only have 32 lights on the screen at the same time. And finally we're just gonna have a small function to do our lighting calculations. Like I said, just gonna start with a hard-coded ambient component, which is gonna be the actual color that we pass. It's gonna be sampled from the color texture, from the normal texture, and from the position texture for each fragment. And then we're just gonna get the view direction, which is pretty much where the camera is looking at, based on its position. And for each light, we're gonna be iterating and adding to the already ambient component of that fragment every of the 32 lights that we got. And for each light, we're just gonna be calculating the diffuse, and with that we just do the regular get the direction, but the same way we did with the view direction, and getting the diffuse, which is the dot product of the normal and the light direction. And we just scale that for our actual albedo and the color of the light. And we do the same thing for the specular. All of these techniques are explained a lot of detail on here, so I don't wanna go in depth into that because people have covered them pretty much better than I. It's right here. You can start with the basic lighting. You can see the ambient is just multiplying it. The diffuse lining is the dot product. Where are you? Yeah, pretty much that. That's the difference on angle. So with that you get your lining. And there's the specular, which also takes into account the position of the viewer. And depending on the angle of the viewer and the light, it gets more bright or less bright. And as you can see, the actual camera position affects also this component, but this is only affected by the normal and the position of the object. And finally we just do an attenuation as we do before, like a non-linear attenuation. And like I said, we just go summing all of those lighting. Basically we just sum the diffuse and the specular and multiply it by the attenuation, and that will be our final lighting color at the end. So what we want to do, now that we have all of this, is just import it into our handy loader. It's gonna be light, oh shit. Then finally, lighting, it's just gonna do the color. It's gonna be equals to lighting, color, what was it? Normal and position. Alrighty. Basically, probably everything's gonna be dark right now, minus the ambient component, even it's kind of really dark. Then you can spot some things there. So let's start setting up our lights. Because right now, because they set those uniforms all are to 0, so basically we don't have any active lights on our scene right now. Alrighty, so we need an storage for our lights, and I think the best place for that is our Steam. So what we're gonna be doing is copying this. Like I say, we're gonna have 32 lights. This probably could be a constant on the future, so we can also have it like as a define in our shaders. But since right now we don't have too much complicated shaders, we're just gonna have it hard-coded as 32 on these two places, and that's it. And like I said, we're gonna store on the CPU part the position and the color, so we can be sending it to the GPU on every frame. And since they are gonna be uniforms, we're probably gonna need them on our uniform lists right here. Again, I have another handy piece of code on my notes that basically is just gonna take whatever array we created before, which is at the end of it just to get the actual number. In fact, it's kind of retarded. Yeah, let's do this, but I don't want to hard code 32 again, so that's what I just reducing this, I guess. Yes. Anyway, at the end of the day, what will happen is we will have one uniform for every 4 lights, and that will be passed to our material. And like any other uniform, it will do the get uniform location for us. It's getting funky in here. Alrighty. Where were we? Still. So we just test this post-processing. Uniforms. Let's check it out. It's not working. I don't know when it's working, but it's boom, it's a bit spammy, but that's the way OpenGL works. Even if it's an array, you need to get an individual uniform location for every of its positions, or at least that's the only way I figured out to do it, so that you can write them. And that's pretty much, we got our locations there, just like all the other uniforms. And finally, on our post-processing pass, we should be setting or shader or lights. Yeah. And where were yes, so basically we're just gonna get our lights from our Steam. There you go. Basically iterate through them. It's gonna be getting the values, the position and the color, of course, and also the index. You will see why in a minute. Open this, and I already have the 2 uniform calls here. Bam. So like I say, for every frame, right before we color post-processing shader, we are gonna be getting the lights from our scene and just passing from the CPU to the GPU with the already cached uniform locations we already get. And that's pretty much it. That will have all our lights ready for our shader. And let me check if I'm leaving something behind. I don't think so. Alrighty. So last step will be actually setting some lights. So let's start with some basic, and in a default one, which probably we could do in here. Get the index. It's too hacky. Well, I guess not. Let me just do if it's the first one. Just so we have always a light on all of our scenes by default. And that's gonna be full brightness. And it's gonna be right on top, I guess. And that doesn't seem to work. Put it down. It seems to work, but it's too attenuated. Oh, there it is. Alrighty.
This is a true love story song. A triumph and a glory song.
Let's leave
With
it
only
here, bro.
one small caveat.
It's just the default light.
It's not the strongest
In fact, it's kind of retarded.
details aren't imperative. What matters is the way it ends. They've got
Default light,
60
even a
mutual
thin.
friends. Animal spirits.
Let's just not do this and force the user of the scene to set their lighting every time. And for that, it's gonna go. I think I already got some sample that I was working on before.
These two are a destined pair. But I checked out their astral chart. This one is a work of art. I know she reads astrology.
Alrighty, so yeah, basically at the end,
But he's quick with an apology.
or any place really of our constructor, right here, we're gonna be setting our lights. We're gonna be through all of them, setting to a random color just to see if it works. As if we got 32 lights. We're gonna be setting them from the -16 to the 16. Spaced 1.5 meters between each other, and on the one, you will see what it is. That's basically just puts one doing like a zigzag pattern. And there you go. Those are 32 lights, and the steam doesn't even seem to bother. Let me check. Ooh, that's a 99% there. I think I never did a WebGL app that takes 99 on my graphics card. But, well, I'm also recording, doing a chroma key, and I'm using a GPU codec for the video. Yeah, there you go, it's 29%. So, yeah. Oh, well, the frame rate is still, I don't know, pretty good, in my opinion. And I can attain 60, so it's like 32 lights with the specular and diffuse. Looks nice. Okay, let's get rid of that ugly triangles and get some better meshes. Start with a sphere. already have like an importer. Let's do 32, 16, I guess, but let's do it of 0.5. That will make it a 1 meter, right. Yes, smooth shaded and spot it. Selection only, handy folder, and sphere. Boom. Now, let's just run our importer. Here goes the ride. Maybe not yet. Alrighty, so that's imported. Let's just check it's there. There you go. Let's just get it. And do the same deal as this one. And instead of this, what are we doing? This. Other change I wanted to do is have a default albedo, which I don't know why I was forcing it, but since it's required, let's just have a default. And that should do. Still -4, 4. Just make this one not. That's weird.
Long flight. It's my first night in Berlin, and I want to dance.
There you go.
Where should I go?
The first shading, my boys.
Or you can go to the Sisyphus.
Anti-aliasing, post-processing.
Oh, the Conscious Club.
What else? Who said the web wasn't for games? Motherfuckers.
Actually, I do, but it's very complicated.
Boom, 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 boom. The monkey boy. Alrighty. Gonna make a quick figure
Welcome to the Conscious Club.
and start with the physics engine. How we doing on time? 43 minutes. I guess to at least do some balls, some spheres, going around on a plane. So let me do maths.
Welcome to the Conscious Club.
One thing I didn't talk about, that I did some fixes. I remember. I guess in case you check it, the repo.
Watch your thoughts. We're going to the Conscious Club every night at 9 p.m. There's a special cat. Get inside and say, I feel, ask you for your chant. Think of something interesting. This isn't relaxation. If he likes
Yeah, basically the retarded thing we had before, that we were binding all our textures, repeating and copy and pasting the same code over and over again. I just changed it to a more functional approach and just go through all textures and do the same thing but once instead of copying and pasting it. Just doing what this comment did, but instead of putting a comment like a lazy boy, actually doing it. And the other thing was pretty much that I fucked up the importer when it comes to the normals importing. Right here, I got some fuck up with the vertex normals. And I wasn't getting them correctly. I didn't understand the structure of the file, of the object I mean. And I was doing some weird shit, but now it's correct. So that's why I pretty much re-imported the monkey. For now on, all of our models should have the normals correctly imported. And that's pretty much all that I did off camera. Just some readme stuff. Because there were some dependencies that weren't updated.
Club is under new management.
So yeah, I set these quick links to the readme so I can check every time if I'm missing some dependency of they're updated or not. In fact, this will show here on green, but I guess they catch it every day or something. And yeah, the same thing for the dev dependencies. You can check if you have some that is out of date, the latest release, the stable version, and whatever you have defined on your package JSON, and it will alert you if there's some new dependencies or updated or whatever. And that's it. So let's do our physics thingy. For that we're gonna be using Canon GS. It's like it says, a lightweight 3D physics engine written in JavaScript. Because this series is about WebGL, not actual physics. So we're just gonna be using this to move our meshes and do some nice simulations. And since our meshes are just a position and like a couple of vectors and a quaternion, it should be pretty straightforward to synchronize the state of our physics world with our rendering. Alrighty, so let's start. Let me see, just one last thing. Looks like I closed it, so I guess we were good with that. Yeah. Also, our second theme probably is fucked. Let me check. I should even just remove it because we're really not using it. In fact, I should do the router more than a physics engine, but I always get sidetracked and never do whatever I say I'm gonna do in the description. Of course, this has no lights, so this thing is fucked. Let me just copy our lightning or second level. What is going on here? We got no normals. We don't. So we fuck pretty much. We're gonna need some normals for the ground. I should really have some classes for this kind of geometries. But for now, let me just make it work. There you go. It's weird, but I don't know, who cares? It's just a test thing. In fact, I'm even gonna remove this one and just leave this thing as a testament that we have stints. That's pretty much it. No need for the standard material. No need for that. to the minimum amount of code so it doesn't break again, or it breaks as less as possible until we start having the router. Alrighty, so the second thing is there. In fact, let me just do something different. See the zigzagging. Alrighty, so second thing works. Let's just fall back to the first one. In fact, let me just check what will it take to just copy one router of the ones that I got, because I'm pretty sure I gotta copy a drop-in router somewhere into here. There you go. Yeah, that's pretty much it, bro. And even has the paths and all, so. And it has an update method. What this does? Just call with the string and the arcs. That's nice. That's pretty much, bro. Let's do this super quick. New router .ds. Alrighty. We're gonna be installing these two modules. This basically convert a URL to an actual regular expression that you can test. You will see in a moment if you have used a React router or whatever, it's the same they use. And the history module is just to actually get an easy API to access the push state or whatever it's called. Just need to actually go navigating through URLs with actually changing the URL. History push state or something like that is called. And yeah, this is basically what we're gonna do. Is see how I did it here. I think it's just the other part of the implementation, which is basically this one. There you go. So the string index, instead of just being the string chassis, it's gonna be like this. Level 01, level 02. And basically we're gonna be mapping paths to strings. So right now all we're gonna do is slash to the level 1 and slash test is gonna be to our level 2. And the path to regex thing serves us because we can then do stuff like this, and then we will receive this parameter from the URL as an object, as a key value object thingy, which is what happens here on the router thingy. Basically, it's gonna get all the things we pass to the path to regex and extract the keys, and then every time the history reaches like the URL changes, it's gonna be calling here, and it's gonna from the path name extract all the keys and see if there's any match. At this any match with any string, it's gonna call the onUpdate function with the actual string and whatever arguments it has extracted from the path. And you will see in a moment. And there's also another handy function to force it to go to some path. So if you can like click on something on the UI and then go to another string and stuff like that. And that's pretty much what this function does. It's like an isolated router to so you can hook up and check on updates on your URLs based on a list of paths. And for that, what we're gonna be doing then, let's check how I implemented that on here real quick, which is gonna be on the engine thingy. Let's go. So I guess we're just gonna have this on our index. Call the setup right here. Alrighty. The streams are gonna come probably. Sorry if I'm making too many jumps here, but it will make sense in a second. I just wanna make this quick so we can focus on the physics engine. Alrighty, so that's gonna be that. Renderer, router, and streams. That's what we're gonna start on our index. Then we're gonna set up our renderer as before. But then what we're gonna be doing, in fact, we should probably want this inside of the renderer, I guess. Because we want access to the router from the streams on the future. Yeah, I guess we want this inside of our renderer. Maybe it should be called engine more than renderer, but who knows. I don't know about that. I don't know, let's just go with this for now. We'll see about whenever we want to use it from inside. Base name, we're gonna be having no base name. Finally, where are you? It's gonna be the deal. Yeah, so pretty much gonna be that. So yeah, it makes every time much more sense to have it inside of the renderer. Yeah. Because then you need to bind this, start being retarded. Let's just make it work. freaking slain, bro. I don't know. I just want to have a router. I will think about a better way to do this later. In fact, we need a way to dispose the things, which we don't have yet. That's gonna be an issue. So let's just prepare it. Here we're gonna be getting the arcs. Just passing this. Alrighty. Finally, we're gonna need this, but I'm not gonna be doing nothing right now, so it's gonna let us do here.
You were the lens I used to see. Sharpen the view, the news, the color TV. Filter the truth through you to me. What's not to trust is just your family.
Alrighty. So let's see if this works. So now if I just go to this last test,
A talk.
of course,
In the dark room, you were
the small change on webpack config.
Overexposed. I blew out
That
and
is
tried to make
history.
it right. That's when Leon came into frame. Yeah.
Is it?
A shadow of the danger of your eyes.
There you go. I guess.
What have you sold?
Start.
What have you done with
Happens to do. Further around. Boom. Then we're gonna go back. So first thing, we got a proper router. But like I say, don't do this too much because it's not disposing of geometry and it's allocating the buffers again and again like a crazy. Do I actually have a dispose on the geometries at least? I don't know which geometries to dispose and all that.
What have you
So yeah, that should be for next episode. Let's just have it there. We know that we have a router, but like I say, don't spam it too much because it's gonna be not disposing all of these messes every time you load this thing, unless you, like I just did, reload the page. But it's good for now. It's just for development, right? How we doing on time? The chat, like 1 hour. Nice. Let's just do some quick physics, I guess. This is gonna be the deal. We're gonna be doing pretty much the same. Just close this. Alrighty. Still here. Guess from this we were done, right? Just checking my own notes for a minute here to see that I'm not missing anything. Oh, and there's one quick fix. That is just on the input. I commented this full screen thingy, but what we're gonna be doing is more like this. Only if it's engaged, we're gonna release it. Whenever we lose the pointer, sorry. So right here. Alrighty, and what we're gonna do is launch it whenever we press the F key. For that, it's gonna get this here, and shall go that, I guess. 70. So funky. And we're just gonna request it. Let me just test that. Press F on the keyboard. Nothing happens. What's going on? What? It's not it. Sorry about that. Just put under this on the class that we wanted. Alrighty, so if I press F, now we go to full screen, and if I lose the lock, we release. Alrighty. That was my last fix on my notes, I guess. Well, also Steam, instead of require a completely new material instance, which is gonna lose all these uniforms and all that, we're gonna be actually using a material, but what we're gonna allow the user to modify are the actual sailors, just but with the same uniform, and maybe in the future we need also uniforms, but I think with the sailors should be just more than enough for now. Alrighty. Just delete this. And let's go with our physics thingy.
Birds of a feather, we rock together. And if we got a problem, we talk together. So let's head down south, escape the bad weather.
Okay, so I can close this for now.
Through my treetop,
And let's create a new file.
washed away. So
Physics, biatch. Magnets.
didn't learn till I went through
What's happening here?
things I didn't know
definitely red. It's weird. I don't know. Alrighty, so first thing first, import our physics engine and create our class as usual. Export it as the default for the file. Module. And of course probably we're gonna be using this physics engine to do the ray casting, and also that we're gonna be having most of our important geometries as bodies. I think we could pull it off to just use the ray caster. But for now let's just focus on having some rigid body simulation. Pretty much this. I'm just gonna create a wall from the physics engine and set this gravity to like an Earth-like gravity. That is like meters per second, I guess. Then we're gonna have a function to step the walls. Pretty much. Which is just gonna receive our frame delta. On the future this will be probably on a web worker or something like that, and just push events to the main process. But for now we just, for simplicity and for also using the ray casting and all that synchronously, we're just gonna have it on the main thread for now, because we are pretty much not doing anything on the CPU so far. And this will be a pretty, well, depends on the number of bodies we add, of course, but so far it should be a pretty not expensive simulation. The clear shirt that is fucking everything up. Oh no. We need also a way to add a body to this thing. Let's get this and simplify it. Super simple. Just gonna have a static and dynamic bodies, and they're just gonna be defined by whatever mass they have. And this is basically gonna be called whenever we add a mesh to the scene. We're also gonna be adding it to our world with some physics parameters and a link to its position and its rotation. We're gonna be constructing a body from that. And also on the shape, it's gonna get the shape. We'll get into that in a second, but basically it's just gonna have a shape, which is gonna be a sphere for now, or a box in spheres of boxes. And this for now is not even gonna be needed also. In fact, let me just do everything here for now. So I'm not even gonna be catching them or nothing. And our shape. And yeah, basically we're gonna create a body from the physics engine with a shape that we're gonna define now, and the position and the rotation of the mesh, add it to the world, and push it to our body list. So then we can do something to all our bodies or stuff like that. I don't really know what we're tracking them so far, but just for now, let's just remove everything and just focus on whatever we want to do. Alrighty. It's not needed either. Mass and right, it's gonna come here through, and finally the shape. We're gonna construct it like this. High field for now. And this is gonna be physics.shape. Nerdy. So this is gonna be our default case. So basically what we're gonna receive in here is pretty much a mass, a shape. With the shape is gonna have basically a type. It's gonna be box or sphere, and a radius, which could be both, just the radius in case of a sphere, or in case of the box, a three-dimensional array with the radius of the box in question. And with that, what we're gonna do is basically create a new body, rigid body. Depending on this mass, it's gonna be static or dynamic. So if it has mass, it's gonna be dynamic. If it's not, it's gonna be static. Then from the shape, we're just gonna construct a new shape from the physics engine and add it to the body. And like I said, just set the copy the position and the rotation, and then finally save the body inside of this physics object. So you will see them later inside of the meshes. We will use this reference to access back the body once it has been stepped. So I think we're golden there. Alrighty, for now we're just gonna add it to the steam to be quick. Maybe there's a better place for this thing, but who cares? Let's call it physics, who cares? Alrighty, so now we have that there. gonna be doing is getting first or ground into the physics engine.
That was cool. That was kind of dope. That was my best take.
Mm.
Yeah, I think one is my favorite so far.
So I guess, yeah, you can just do this. Physics mass 0 shape. It's gonna be of type box. And it's gonna have radius but this will come from the geometry, not from the mesh, but I don't know, we also need to catch these shapes, but I don't know, let's just make it quick. How am I doing on time? I don't know why I always get into this super late. Let's just have it working with just one ball. And then, but yeah, this will come from the geometry, definitely not from the mesh, because we want to be reducing at least the shape for every instance of the same geometry. But for now, let's just do this. Since it's gonna be a radius of 10, let's do a 10, 1, 10. That should do. And let's quickly do this.
Yeah, burning up in the first stab.
Great take.
I guess that will do. Let's just order that there.
Anytime you think about her,
And what else?
feelings they was thinking
Then
about
we
you.
can just do this physics, add body,
Oh, and anytime
mesh physics.
see you in the street, the choice is there. Just gotta see you after you're through. Oh, I gotta believe it, baby. Ooh, you're thinking about me, maybe. Ooh, I don't know what you're thinking about any other day. When you keep on running away, running away, running away, running away. I try not to expect much anymore. It's over now. Why won't sit off for won't see?
We'll just do the same for sphere. Not animated. Finally, just do it here for now. So quick thingy. To start stepping the world. Just do it here. That's the delta, right? After this, we're gonna be very much extracting the position. It's gonna be right here, I guess. There we go. Alright, so we actually have some physics on the object, and we have added the body, and the type is actually probably just dynamic, and it's not sleeping. We just get from the body the actual position and quaternion, and we update, which we're gonna do with like 3 matrix. I'm just gonna be doing back 3 set position X. Oh shit. Let's do P and R. P set. And the same for our rotation. Shit. Alrighty. So that should do. Let's see what happens. It's not moving. And probably, of course, we need to update. Since we just changed the position and the rotation, we need to, in fact, let me get the mesh right here. It's gonna be much better. Let's do this. Here we're just gonna be updating the mesh transform. Alrighty. What is going on? Are we even getting into here? Yep. What happened there? Doesn't look like it. So we're fucked from the beginning. That's all physics.
Good man gives the love you never got. I want something Hamish to do it like the Danish. I can't change your feelings, but feelings they can't change. Smart enough to understand the game, but don't say it don't mean a thing. Let's keep it business.
Let me check that then.
Let's keep it fun for you and me, so you can see how we win history for business. Let's keep it casual. Let's keep it fun for you and me, so you can see how we win history. I got my PhD, you beat my dissertation. I got my CPA, you beat my signatory. Oh, Steve from Steve Jobs.
Shit, I didn't add it. That's it, right? Let me see. I probably didn't. There you go. I'm stupid. Probably we should centralize this somehow in the future, but for now. But let me get that from all context. From the class context, I mean.
Everyone's talking about flying through the mountain. I just want to talk about hiking all the way up and keep it business. Let's keep it casual. Let's keep it fun for you and me, so you can see the win history for business. Let's keep it casual. Let's keep it fun for you and me, so you can see the win history for business. Casual. Fun.
Of course.
Business. Casual. Fun.
Seems like it has moved, right?
Aim it for the peripatetic. Business. Let's keep this fun. Just you and me. Just you and me. Keeping it fun. Keeping it fun. Let's keep it fun for you and me. So we can see business.
That's the radius, right? Let me check. It's the radius, right? Let me check here. Well, it's going into there. Yep, it's updating. My bad. Oh shit. Our ground is too up, probably. That's it. But this is kind of redux because I can just do this, right? In fact, yes, let's just do this. And let's just put a floor. It's probably wrong because it's one. So it needs to be shape. We need the shape offset, bro. For starters in here. It's gonna be like a 1 of radius on top and on the bottom. So we just want it 1 meter down. So it's at the same, the top face of the box is at the same level of our ground. And for that, just gonna quickly go to what I have right here that I courageously deleted before. So that should do right here. Boom, boomy boom. And here we got some shape offset. I'm gonna be applying it, and if not, let's just be more specific and say and define. Alrighty, so our ball is on the ground, nice, and what is not moving. Let's pull it up and see if gravity does something to it.
Just believe and that it will make it true.
Let's make it like a 10, I don't know. That is fast. Let's put it in front, bro. Boom, that's really fast. I don't think our delta is correct. Because probably is expecting it on seconds. On milliseconds, I mean. And our delta is on actual seconds. So let me check. Let's step in. No, she's in milliseconds. Yep. So that's pretty much it. That's gonna be whenever we step. It's 5001. That looks more like it. Boink boink. And I don't know, let's just put in a rotation or something to see if it rolls. It's gonna be rotation. It's gonna be a new quad. And let's just rotate it some random amount. On like every axis. I think I need to apply a bit of impulse or something. Or make it collide to something else. Let me just do the applied impulse thingy then. I'm getting out of time, but I think I already got something for that very purpose. We will see about constraints and all that later. For now we just want this. Oh, that seems cool. So let's just have it as a static on the top. 1, 2, boom, 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 boom. So it's gonna apply whatever impulse we want on the very center of mass.
This is the story of Captain Hook, a young
And we just pass the body. Cool. So
singing hooky hooky gibberish into his phone. There's no need to steal from Marvin Gaye. When the hottest hooks are public domain,
just gonna have it
Silver's got a misdemeanor. I'm made up for the felony.
0.5, so it rests on the ground.
In the mix, I still make hits that don't even rhyme, that aren't even in time.
Let's just do.
Captain Hook. I'm Captain Hook. I'm Captain Hook. I'm Captain Hook. Through my veins, the chorus is coursing, mainstream and delicious like Morrison. Franchise the verse in a spin-off. I'm
I guess.
cleverest on a Wim Hof. I'll make your mother proud of you.
The family unit.
I slow down when others go faster. Forget the writing, I own the master.
Nice and low volume.
Take
Cool.
delivery. Learn something edutainment. Focus on your breath, I'm a brain man. I'm Captain Hook. I'm Captain Hook. I'm Captain Hook. I'm Captain Hook.
We're just gonna be applying, what was it? The impulse, which is pretty much an array. We're gonna be pushing it up,
Bad weather. Go get
back and to the left.
Get her bootstrap. Bad
Alrighty, let's do that. Back and to the left. Up.
Go get her.
Just another J rap.
Get her bootstrap. Bad weather.
Back and to the left. Boom. Oh, that's too much.
I'm Captain Hook.
He's very talented.
I'm Captain Hook. I'm Captain Hook.
He's very talented.
Hello.
Captain Hook.
He's very talented.
I'm Captain Hook. I'm Captain Hook. I'm Captain Hook.
A tomar por culo. Alrighty. So I think that makes our chapter for today.
And I'm P-Mo, baby.
Right, so apply it to the walls also. And do some more bar think I'll just be doing some sting on Blender and importing it to here to have all collisions. Maybe we can start doing some spawning of meshes, like when you click start firing balls and see them collide and stuff like that. Cool. I don't know. I guess that's gonna be it for today. Let me just not do that. A little bit to the left. That's way too much. Just wanna keep it inside of the plane. But it seems to want to go over the place, all over the place. This is that one, so it falls. Ooh. It's quite an impulse, bro. There you go. That should do for me. Alrighty, so this is it. Let me just commit this puppy. Six already. Holy shit. Nice. Boop, 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 boop. Attack. 6. And yeah, next time try to start to having some procedural geometries, I guess, like a height map, probably like a voxels measure. And yeah, pretty much that. Keep doing some more things with the physics engine, like some constraint for doing hinges, instancing meshes and shooting them, stuff like that. Maybe do some collision with the player. I don't know. We'll see. Stay tuned. I already pushed it, right? Alrighty. So then I will upload a screenshot and all that goodness later. Check it's all there. There you go. Alrighty. So as always, thanks for watching and see you on the next one. Bye.